So the Chapter 11 review that you see here, we're going to do it together. Turn it in as soon as you are finished. Chapter 11 was a lot about systems of equations and inequalities. So let's start with problem number 1. In problem number 1, if you see a system of linear equations, we are looking for the point of intersection. What do they have in common? I tend to use, for a system like this, I tend to use elimination. What I decided to do, and there's multiple ways to do these problems, was to multiply this equation here by 3. If we multiply that one by 3, our top equation, I haven't touched, because what happens when you multiply it by 3 is the bottom equation, you will notice that those x's became opposites, okay? So when those x's are opposites like that, then when we add those things together, these x's will cancel out. And then that's our goal, to get one of the variables to be eliminated. So that's what happens. We get a negative 5y plus 12y is 7y, and then 10 minus 3 is 7. So it becomes a nice algebra from there. Divide both sides by 7, and we get y is equal to 1. Now remember, we're not done for a system until we find the point of intersection. So we need both the x and the y. Now it doesn't matter which equation we use at this point. I decided to use the top one, where y was sitting, I plugged in 1. So if you plug in 1 to this equation for the y, we get 3x minus 5 equals 10. Add 5 to both sides, we get 3x equals 15. Divide by 3, we get x equals 5. Now don't finish it like that. It's an ordered pair. It is a point of intersection, so write it as a point. So the point of intersection for number 1 is 5, 1. Okay. That is not the only way you could have done this problem. You could have tried to solve for a particular variable, use substitution, eliminated the y's. That's just the way that I decided to do that particular one, okay? Any other, or any questions about number 1? Okay, let's do it again for number 2. I decided to use elimination again for number 2. Let's multiply the top by 3 and the bottom by negative 4. What I'm trying to accomplish this time are to get my x's to be opposites. That will make this a 12 and this a negative 12. We want them to be opposites. Okay, so let's do that. If we multiply everything on the top equation by 3, we get 12x plus 6y equals 30. And if we multiply the bottom equation, everything by negative 4, we get negative 12x minus 36y equals 0. And then I'm going to add those two together so that my y's are eliminated. So 12x and negative 12x is the thing that is eliminated. My x's are gone from the equation. And then if I combine the y's, I get negative 30y equals 30. So when I divide both sides by negative 30, I get y equals negative 1. Now I'm not done, because remember, we want the ordered pair, the point of intersection. So we can plug it in to either equation. I'm just going to plug it in right here at the top. I get 4x minus 2 equals 10, because 2 times negative 1 gives me the negative 2 that you see there. And then just solve. Add 2 to both sides. We get 4x equals 12, and then divide both sides by 4. You get x equals 3. And then write your answer as an ordered pair. So the ordered pair is 3, negative 1. So that is about our systems of linear equations. Again, that's just one way to solve that problem. There are multiple ways to solve these particular problems. Any questions about 1 or 2? Okay, we're going to skip 3, and we're going to jump to problem number 4. So if you could please jump to number 4. Now 4 is 2 nonlinear equations. The top equation is actually a circle. The bottom equation is what's called a hyperbola. And we're actually going to find, it's going to end up looking like that if you were to graph it. We're going to find that this system intersects in 4 different points. So it's kind of an interesting one. When I see a system like this, I try to find what do they have in common, what do they have that could possibly be eliminated. And if you notice, these two are already right off the bat opposites. So that means the y's can be eliminated from my problem. So you are allowed to just add the 2 equations together. So that's a nice thing to do. So when you do that, you get x squared plus x squared is 2x squared. And then 25 plus 1 is 26. Okay, now from there, where do you go from there? Well, to solve a quadratic that's like that, I think the most efficient way is get the x squared by itself. So let's divide both sides by 2. And to get rid of a square, we're going to square root. But what do we have to remember to put in front of the square root? What do we have to remember? When we inflict the square root, what do we put in front of it? The plus or minus symbol. So that's plus or minus the square root of 13. Now, if that could be reduced, please reduce it. It can't be reduced, so that is your x value. So that means our x value, we got 2 x values that worked. Now let's think about if we plug it in. I'm going to plug it into this top equation. I'm going to plug in positive square root of 13. Whether I plug in positive square root of 13 or negative square root of 13, when I square a square root, it becomes just the thing inside. So if I plug in positive square root of 13 or negative square root of 13, right here, I get 13. So I get 13 plus y squared equals 25. Now, get your y squared by itself. So it becomes similar to what we did earlier. Subtract 13 from both sides. 25 minus 13 is 12. So y is plus or minus the square root of 12. Now, the square root of 12 should be written a little nicer. Don't leave it square root of 12. The square root of 12, since 12 is 4 times 3, is really 2 radical 3. So let's write that as plus or minus 2 radical 3. Now, how do you write the ordered pairs? Okay, what are our ordered pairs? There's actually 4 of them there. If I start out with an x of positive square root of 13, I can get 2 radical 3. Or I can also get negative 2 radical 3. We saw that when we plugged in square root of 13, we got 2 answers. So here's the positive and here's the negative. And let's just write it one more time. If I plug in negative square root of 13, I get 2 radical 3. Or also negative 2 radical 3. And if you were to graph it, it does look something like that. Obviously, Decimus will give you a much nicer version, but it does actually cross each other in 4 locations. So there are times where we can get lots of points when we are dealing with nonlinear equations. And that's what happens with this particular one, okay? So just remember, if you have to inflict a square root in the problem, put that plus or minus. If you don't put the plus or minus, you're going to end up missing some points that are actually in there. Okay, so that is problem number 4. Anybody have any questions about that one? Okay. So next we're jumping to the word problem we see here. Let's take a look at that. A fair charges adults $2 and children $1.50. 425 people attended and $700 was brought in. How many adults and kids attended? Now for a problem like this, there are usually 2 equations, one about the total and one about the value. Okay? So if we call X the number of adults and Y the number of kids, let's talk about the total people attending. x plus y, the total attending was 425. So if we call x the number of adults tickets and y the number of kids tickets, the total that attended was 425. Now there's also information they gave us about the value. Okay, now adult tickets were $2, so 2x. Kid tickets were $1.50, so $1.50y. I'm just going to put 1.5y. Will equal a total of monetary value is 700. So those are the two equations that we have. Now earlier when we did these, for both of our linear equations, I used elimination. So at this time, you can use elimination. Go for it if you want. But I'm going to use substitution. Okay. So I'm going to take this equation here. I'm going to move the x to the other side and make it that y equals 425 minus x. So all I've done is I have moved the x to the other side, just subtracted it. Okay. Now, what I know, that's what our y is equal to. So I can take out this y right here, and by substitution, I know y is equal to 425 minus x. I'm going to take out the y. I'm going to put in 425 minus x. So I get 2x plus 1.5 times 425 minus x should equal 700. Now, what you might notice then is that now we have an equation that only contains x's, which is great. And think about how we would solve it. The first thing we have to get rid of is this 1.5. Let's distribute. Okay, so we get 2x plus 637.5 minus 1.5x equals 700. Now it's starting to look a little more like a simple equation. We can put the x's together. We can put the numbers together. This does say 637.5. Now, let's subtract 637.5 from both sides. Let's combine our x's. Okay, first, if we combine our x's, 2 minus 1.5 is 0.5. If I subtract 637.5 from both sides, I get 62.5. And then I just have to divide both sides by 0.5, and I know what x is. And x happens to be 125. Now, let's remember what that was. That was the adults. So there were 125 adults that attended. But we still haven't answered the question in full because they asked how many adults and kids attended. Now remember, kids are the y. So y is 425 minus x. So just subtract 425 minus 125, and we get 300. So that's kids. So now we've answered the question more thoroughly. We have 125 adults attending and 300 kids attending, okay? And so that is, there's a word problem number 5. Any questions there? We good? Okay. We are going to skip number 6, so just go ahead and cross that out. We didn't do much with linear or nonlinear inequalities that look like that. We didn't have time to get to that. But we did do ones like number 7 and 8 and 9 and 10. So let's finish up and do those ones together. Now, 7 is a nonlinear inequality. It's in factored form. You'll notice this is factored, and it's related to 0. So we're ready to go and solve it. Okay, so remember what we're going to do. We're going to set each piece equal to 0. We're going to put those on a number line. Give yourself a little room above it. Now go back to the symbol. If that's an equal to symbol at this point, color those in. And now let's make that into a chart. There were 2 factors, so I need 2 rows. Now we're going to put test numbers in there so that we can determine whether the area we're looking for is positive or negative. I'm going to go -3, 0, and 4. There are millions of choices. Those are just the choices I picked. I do tend to put in nice integer values when plugging in, if possible. Now, if you plug -3 into both of those values, -3 will result in -1 in the top, so a negative in the top, and a -5 in the bottom. Two negatives when multiplied together give me a positive. Now let's plug in 0. I get a positive and a negative. When multiplied together, that gives me a negative answer. And then if I plug in 4, I get a positive and a positive, which gives me a positive answer. Now my less than or equal to tells me that I am looking for the negatives. I already used the equal to part, that's why I colored in the dots. But that tells me to color in the negative. So the only negative is this region here. I'm going to make that a little darker. And then I'm going to write my answer in interval notation. I want the x's starting at -2, including that with a bracket, and stopping at 3, including that with a bracket. So that is how you do number 7. Do we have any questions about number 7? Okay, so now let's go ahead and look at number 8. Do you notice what the difference is between 7 and 8? What's the difference we notice? Yes. Yeah, it's not in factored form yet. So first step we have to do that's a little different for number 8 is let's get it in factored form. The factors of 8, for number 8, the factors of 10 that have a difference of 5 is let's say that again. The factors of 10 that have a difference of 3 are 5 and 2. So we're going to need that to be a -5 and a +2. Okay. Now it looks very much like number 1. We're going to do the same things. We're going to set each factor equal to 0. We're going to solve each one. We get factors of 5 and -2. We're going to put those on the number line in numerical order, least to greatest order. Now this time, when we look in the problem, there is no equal to on that little inequality symbol. So because there's no equal to, please put an open circle on each of those, and then make that a chart. And then we're going to put our factors, x minus 5 and x plus 2. We're going to choose some numbers. Let's choose -3, 0, and 6. And you're going to find the same thing happens as we saw in number 7. These two are going to be a negative, which gives us a positive there. This is going to be a negative and a positive, which is a negative there. And then this one is a positive and a positive, which is a positive there. Now this time, the greater than symbol tells me that I want a positive value, so color in the positives. Now these are the ends that are going to -infinity and positive infinity, so we're going to have to use that when we put our answer in interval notation. So our answer goes from -infinity to -2. And then from 5 to infinity. Make sure this time to only use parentheses because of the fact that we don't have that equality symbol. We don't use any kind of brackets. So those are kind of the more traditional quadratic type of inequalities. Or do we have any questions about 7 or 8? Okay, good. We've got 2 more to go. We'll do 9 and 10, and then you'll turn this in. Okay. Now for 9, if it needed factored, we would factor it. If it needed related to 0, we'd take care of that. But these ones are ready to go, so I would suggest putting top and bottom in parentheses as kind of just the first step to really make those factors kind of pop out. We're going to set each one of those factors equal to 0 like we did before. So where does x plus 1 equal 0 and x minus 2? And then you're just going to solve those like we have done before. So we get an x value of -1 and an x value of 2. And we're going to put those on the number line from least to greatest order. Now, for any factors that came from the top, so you'll notice this one came from the top. For those factors, we're going to look at the symbol. So if we look at the symbol has an equal to bar, and so that one is allowed to be equal to 0. But any factors that come from the bottom, no matter what the symbol is, are always an open circle because denominators aren't allowed to equal 0, so we are going to leave that one open. Now that we've determined who gets an open circle and closed and so on, now we are going to make our chart. Same thing as before, we are going to choose some values. I am going to choose -2, 0, and 3. When I plug those in, I get a negative, and a negative when divided is a positive. I get a positive and a negative, which is a negative. I get a positive and a positive, which is a positive. Now, don't expect that that's always going to happen very much. You know, that's very a common pattern, but just be careful. Less than 0 means that we need negatives now colored in, so we color in the negative only in the middle. And our final answer is we want x's between -1 and 2. And you'll notice that the -1 got a bracket because that came from the top and it had an equal to symbol in the problem. But the 2 came from our denominator, so it has a parenthesis. Denominators will always have an open circle on them, so a parenthesis. Everyone good for number 9? Okay, one last one. Let's do number 10. And then you're ready to turn this in. This time we have 3 factors. So we're going to set all 3 of them equal to 0 and solve. So we're going to get x minus 1 equals 0, x plus 1 equals 0, and x minus 3 equals 0. Now that's going to give us 3 different values, -1, +1, and 3. And it just so happened that they are in numerical order, which is great. So -1, if they weren't, put them in least to greatest order. Now the top ones are determined by the symbol in the problem. The symbol in the problem does not have an equal to. So the top factors of -1 and +1 are open because the symbol doesn't have an equality to it. The 3 is in our denominator, so it's always open. We're going to make a chart. This time we need 3 sections. We need a section for x plus 1, x minus 1, I'm sorry I switched those around, but it doesn't really matter, and x minus 3. Okay, let's choose some test values here. Let's go -2, 0, 2, and 4. Those should work pretty good. Okay, let's plug -2 into each of our values here. We get negative, negative, and negative. 3 negatives are going to multiply or divide, doesn't matter which, and stay negative. Remember, odd number of negatives are going to stay negative. If I plug in 0, I get a positive, a negative, and a negative. 2 negatives make a positive. Now let's plug in 2. When you plug in 2, you get a plus, and a minus. 1 negative is going to stay negative. And then finally, when we plug in 4, we get positives down the board, and all positives are going to remain a positive value. Now, what do we color in? We'll go back to the original symbol. The symbol that we have there is a greater than symbol. That means we are looking for greater than 0 means positives. So let's color in the positives. And then we can write our answer, and then we're good to go. Okay. So our x's would be between -1 and 1. Use parentheses, no brackets. And then our last piece there on the end goes from 3 to infinity. Again, you'll notice I've used parentheses. Okay, so that is pretty much everything from chapter 11. That's kind of a little review. We're kind of done then with chapter 11. That's as much time as we can spend on that. So turn this in at this time. Get yourself some points. And there you go with the chapter 11 review.